Welcome to 7.2 Notes for Algebra 1C. Today we are multiplying polynomials. We're going to start with multiplying binomials, which you remember from last lesson is just a polynomial with two terms. So a two-term polynomial times another two-term polynomial. This is also referred to as double distribution. And this is most of what we're going to be doing. So this will be an important section to talk about, specifically when we multiply two binomials together. So when we multiply a binomial times a binomial, we're going to use the double distribution method. Our steps are listed right here. So first we're going to distribute the first term to each term in the second binomial, then distribute the second term to each term in the second binomial, combine like terms, make sure your answer is in standard form. That's a lot of jargon, but let's just do an example and you'll see how this comes together, okay? So in our first example, x minus 4 times x plus 3, those are our two binomials. Okay, we're going to take our first term x and we're going to multiply it times x, right? That's how we get x squared. And then x times 3 is how we get 3x. And then we're going to do the same thing with the second term. So negative 4 times x is negative 4x, and then negative 4 times 3 is negative 12. When we combine our like terms, if you look in the middle here, we have 3x minus 4x. That is what makes our negative 1x in the middle. So remember, combining like terms just means add your coefficients and then keep the variable the same. Another way to do the same problem is called the box method. So this is our double distribution, and this is what we call the box method, or expansion box method, okay? It's the same thing. It does the same thing. We're still going to end up with four terms. As you can see in our box, there's four spaces. It's just a way to stay organized so you don't miss anything. So what you can see is we did our x minus 4, and we did that going down. So here's x. X is our first term, minus 4 is our second term. And then our second binomial, x plus 3. X plus 3, so this one's across the top. And now what we're going to do is when we multiply, we're going to just take one box at a time. We're going to multiply whatever's on the edges. So for this one, x times x is x squared. For the box to the right, we're going to do x times 3, which is 3x. And if I move to the bottom left, we've got negative 4 times x is negative 4x. And then finally, our last box is negative 4 times positive 3. I'm looking on the edges. And we get that. So we should still get the same four terms that we got in this step right here, right? And we still need to write our polynomial in standard form and combine like terms. So I'm going to start with my biggest exponent is x squared. Then our next biggest exponent is x. So you'll see these kind of tend to line up on the diagonal. Not always, but often. So those combine to negative x. And then finally, our constant term is negative 12. So we get the same exact answer, right? Either way, there's two methods of doing the exact same thing. So that's pretty much all we need to know. Now let's just do a bunch of examples just so we get used to doing this process. It's just going to be a lot of practice until we get it right, okay? So our first example, number one, we have n plus 2 is our first polynomial times 7n minus 4. So you can use the double distribution or the expansion box method. Choice is yours. So n times 7n is 7n to the second power, or 7n squared. N times negative 4 is negative 4n. And then we move to the second term. 2 times 7n is 14n. And then 2 times negative 4 is negative 8. So our middle terms are often going to be our like terms. So we should just make sure we check, combine like terms. So 7n squared, these two middle terms are going to become, well, negative 4 plus 14, or 14 minus 4 is positive 10n, and then minus 8. So there's our answer in standard form. Remember, we're always writing our answer in standard form. All right, let's do another one. So first term, so this one, again, if you want to use that expansion box, we absolutely can. Let's try this one with the expansion box. Any of these we can do with the expansion box or without. So 2x squared minus 6. So 2x squared and minus 6 go along one side. 5x squared and 3 go along the other side. Remember, just one at a time. One polynomial goes down a side, one goes across. Let's do this first box here. I always start with the upper left. 2 times 5 is 10. X squared times x squared is x to the 4th. Next box is 2 times 3 is 6 and x squared. Bottom left is negative 6 times 5, so that's negative 30, and we have x squared. And then negative 6 times 3 is negative 18. Make sure you keep your signs in there, okay? And now we're just going to write our answer. So we have 10x to the 4th. Whoops. 10x to the 4th. So used to writing x squared. Our middle term is going to be the combination of negative 3x squared and positive 6x squared. So that's going to be negative 24x squared. And then finally negative 18. So first term, middle two terms combined, and then our last term, so we ended up with a quartic trinomial in standard form. Remember, we're always starting with our highest exponent and working our way down. Okay, let's try these last two. We're just using the double distribution method. So a times a is a squared. A times 3 is 3a. 7 times a is 7a. And then 7 times 3 is 21. Combine those middle terms, write those a terms. So we're going to get a squared plus 10a plus 21. Another quadratic trinomial. And our last one, so b times b is b squared. B times negative 2 is negative 2b. Negative 6 times b is negative 6b. And negative 6 times negative 2, watch your signs here, is positive 12. Combine your middle terms. Those are both negative, so they're going to make a bigger negative. So we're going to end up with b squared minus 8b plus 12. So a lot of times, like look at this, 1, 2, 3 quadratic trinomials. So that's often what's going to happen. Number 2, we started with quadratics, so we ended up with a quartic trinomial. Very similar, but a little bit different. Okay, when we have a binomial that is squared, we have to expand before we can multiply. So basically, we just have to make it look like what we just did. So remember, if we square something, it means times itself. So if I see x plus 3 squared, that really means x plus 3 times x plus 3. And now we can multiply it out, just like we did before. So x times x is x squared. X times 3 is 3x. 3 times x is also 3x. And 3 times 3 is 9. Combine those middle terms, we're going to get x squared plus 6x plus 9. Okay. 3x minus 5, quantity squared. So again, expand it to 3x minus 5 times itself. And we're going to double distribute. So 3x times 3x. 3 times 3 is 9. X times x is x squared. 3x times negative 5 is negative 15x. And then we're going to have another one of those. So negative 5 times 3x is also negative 15x. And then negative 5 times negative 5, watch your signs, this is going to be positive 25. Combine your middle terms, so we're going to get 9x squared minus 30x plus 25. Remember, you can slow down these notes or rewind and rewatch or pause at any time. So if you have questions, take a minute and watch through it again, pausing if you need to, okay? All right, n minus 1 squared. So again, we expand to n minus 1 times n minus 1. and we double distribute. So n squared minus 1n, negative 1 times n is another minus 1n, and then negative 1 times negative 1 is positive 1. Combine your middle two. We get n squared minus 2n plus 1. All right, last example here, c plus 7 quantity squared. So again, c plus 7 expands, because we're multiplying it by itself. C times c is c squared. C times 7 is 7c. We're going to have another 7c. And then 7 times 7 is 49. So again, combine your middle terms. 7c plus 7c is 14c plus 49. So c squared plus 14c plus 49. So in all of these, it looks like, let's just take a minute and notice something here. So when we have this, these ones that are being squared, look what happens in the middle here. We had the exact same terms that combined, right? The exact same terms. The exact same terms and the exact same terms. So that's always going to happen with these. That's kind of just a pattern that we're going to see. Okay, so just something to think about. When we get to our, a little bit later when we start factoring, that might be a little bit important. Okay, we're going to talk about conjugates. Conjugates are binomials that have this, that are the same except for the middle term. That should be middle sign. Middle sign. Okay. This again will really help us when we start factoring, right? So this is a really important one to pay attention to, okay? So let's see what happens. So these are conjugates, right? X plus 6, x minus 6, they're exactly the same except for the middle sign. Okay, so that's what we call conjugates. So let's see what happens when we multiply. X times x we know is x squared. X times negative 6 is negative 6x. 6 times x is positive 6x. And positive 6 times negative 6 is negative 36. Well, here we have almost the same terms in the middle, but the signs are different because this wasn't a perfect square like before. So these guys are actually going to cancel out. So we're just going to get x squared, and then our last term, which is minus 36. Okay? So that's it. We end up with a quadratic binomial instead of a trinomial. All right, let's do another one. All right, 2x times 2x is 4x squared. Multiply. 2x times 3 is positive 6x. Negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. Again, these middle terms are going to cancel out, leaving just 4x squared and then minus 9 at the end. And we call this pattern that results, we call this the difference of two squares. Right, x squared and 36, 36 is 6 squared. 4x squared minus 9, 4x squared is a perfect square, 9 is a perfect square. Okay, let's take a look at our next one here, number 11. X times x is x squared. X times 3 is 3x. Negative 3 times x and negative 3 times 3. Middle terms are going to cancel out, so we get x squared minus 9. Okay, and again, n times n squared. N times negative 8, negative 8 squared, or n, sorry. 8 times n is 8n. And 8 times negative 8 is negative 64. Middle terms are going to cancel out, so we get n squared minus 64. Difference of two squares. So two squares, n squared and 64. Difference means subtracting. Okay, so let's just do a little bit more with this expansion box. This is where it's going to be really useful, is if we do a larger polynomial or multiply larger polynomials. So this is no longer a binomial times a binomial. This is a binomial times a trinomial. So we're going to find the side that has 2 boxes, and we're going to put our binomial down that side, so 3x plus 2, 1 term in each box. And then our trinomial on the top, right? So that's 6x squared is our first term, minus x is our second term, plus 4 is our third term. So now we can just multiply to fill in these boxes. So 3 times 6 is 18. X times x squared is x to the third. And it's going to go across. Negative x times 3x. So negative 1 times 3 is negative 3. X times x is x squared. And then our last box is 4 times 3, which is 12. And we have 1x. So you see how all the exponents are different? That should always be like that. Okay? If you multiply x and get x, right, you end up with 2 x terms. That's where something's going to go wrong. So make sure that you're checking your exponents as you go. All right, bottom of this box, 6 times 2 is 12, so plus 12x squared minus 2x plus 8. Okay, again, every box has a different exponent. If I look on the verticals, they should all be different. So now we can write our standard form polynomial. So starting with x to the third, we have 18x to the third. Then we have 12x squared minus 3x squared, so that's going to be 9x squared. 12x minus 2x is 10x. And then finally plus 8 is our last one. So we end up with a cubic polynomial with 4 terms. Okay? So you can use that for any size polynomials, but it's especially helpful when we start multiplying bigger polynomials together, because we had 6 terms there before we combined, so that way we don't lose any of them. All right, last topic is perimeter and area. So we need to know what perimeter is and what area is. Perimeter is the distance around a shape, and we find perimeter by adding all the sides together. Right, so if I have a perimeter, if I have a rectangle, right, I have a length and a length. I have a width and a width, right? So it's 1, 2 lengths, and I have 1, 2 widths. So that's my formula. 2 lengths plus 2 widths equals the perimeter. Units are always linear, as in not squared, right? So meters, centimeters, feet, things like that. The area of a shape is a 2-dimensional space within a shape. So same shape, right? If we have a rectangle, length times width, right? If you're going to find out the area of a room, if you're going to buy flooring for a room, you need to know the square area. So it's length times width. Area is length times width. But because we're multiplying here, not adding, right, we're going to have a squared unit. So meters squared, centimeters squared, or square feet, something like that. And sometimes we write out square feet, or you can do feet to the second power. Either way is fine. So let's find the perimeter of this rectangle. So here we have 2x plus 2 meters for the width. We have 4x plus 3 meters for the length. So what we're going to do is we're going to set up our equation. Our equation was P equals 2L plus 2W. So I'm going to write P equals 2 times the length, so 4x plus 3. We'll worry about the units later. Plus 2 width, so 2 times the width, which is 2x plus 2. So I'm going to need to distribute that 2, right? So this is going to be 8x plus 6 plus 4x plus 4. And I'm going to need to combine my like terms, right? So 8x and 4x is 12x. 6 plus 4 is 10. And our unit here is meters, right? So this is meters. So our perimeter is 12x plus 10 meters. Okay. Now we're going to do area. Area is length times width. So length is 4x plus 3. The width is 2x plus 2. Right, this is our formula. Area equals length times width, which is right up above here. So now we have to double distribute. So 4x times 2x is 8x squared. 4x times 2 is 8x. 6 times 2x is 6x. And 6 times 2 is 6. Again, don't forget to combine those middle terms, right? So this is going to be 8x squared plus 14x plus 6. And what is our unit going to be? Well, if we started with meters, this is going to be in meters squared. So square meters or meters squared. So area is always going to have a squared unit. Perimeter will have a linear unit. And that's all for our notes today.